All right, here we're looking at a partial fraction decomposition problem. We can tell it's partial fractions because we see a polynomial on the top and a polynomial on the bottom. The degree of the numerator is 2, the degree of the denominator is also 2. That means we need to do long division. You need to do long division anytime the degree of the numerator is bigger than or equal to the degree of the denominator. So I'm going to do some long division maybe over here. I'm going to put x squared minus x minus 2 and x squared minus 3x plus 8. Remember, the numerator always goes inside the house, we say. X squared goes into x squared once. 1 times x squared is x squared minus x minus 2. We're going to say minus this quantity. The x squareds cancel, as should always happen. I know I might be kind of glossing over this long division, so if you feel unfamiliar with this long division, you might want to watch another video that shows you how to do this long division, so I'm kind of speeding through it. Negative 3x minus negative x makes for negative 2x. And then we have 8 minus negative 2 is plus 10. So this is our remainder because x squared does not go into negative 2x plus 10. So this partial fraction over here can be rewritten as the integral of 1, that was our quotient, plus the remainder of negative 2x plus 10 over x squared minus x minus 2. Now, before I actually write that x squared minus x minus 2, I'm going to go ahead and say, you know what, I can factor x squared minus x minus 2. I can factor that into x minus 2 times x plus 1. Okay. Long division's done. Step 2 is to set up our partial fraction skeleton. What I mean by that is check out these two denominator terms. These are linear factors. We can tell they're linear factors because there's not an x squared plus 1 or an x squared plus 2 or an x squared plus 4. They're just x minus 2 and x plus 1. Furthermore, they're linear factors, or they're single linear factors because they're both being raised to the power of 1. We would call them repeated linear factors if the powers on either of those guys were 2 or 3 or 4 and so on. So these are just really easy, really simple, nice simple linear factors, which means the decomposition of this, and I'm just going to be decomposing this, I'll deal with the 1 in a second. The decomposition of this for the skeleton is a over x minus 2 plus b over x plus 1. Okay, that's the partial fraction skeleton. Again, I'm not dealing with the 1, I'm going to leave that alone. I'll come back to him later. I just want to deal with the a over x minus 2 plus the b over x plus 1. All right, now, the next step is to get a common denominator with these terms. And notice, a needs an x plus 1 that it doesn't have, and b needs an x minus 2 that it doesn't have. So I'm going to give these guys an x plus 1, and the b is going to pick up an x minus 2. And in doing so, the numerator becomes ax plus a. I'm just distributing the a to the x and to the 1. And I have plus bx minus 2b. So I'm distributing the b to the negative 2 as well. All right, now, we set this numerator equal to our original numerator, which was negative 2x plus 10. We've got this equality here. Now the next step is to group in powers on x. Now that step kind of seems a little confusing. What do I mean by that? I mean, I want you to look at all the x terms that are on the left-hand side and all the x terms that are on the right-hand side and set them equal to each other. That is, we see that, let's start with our x terms. I see the highest power on x I have is x to the 1, right? These are all x to the 1 powers. The highest power I see is x to the 1, and I see negative 2 on this side, negative 2x to the 1 on this side, and I see a plus b on this side. Then I'm going to skip down to my constant terms. I'll call that C-O-N-S-T for constant. Go figure. What constant terms do I have on the left side of this equation? I see a 10. And on the right-hand side, I see an a and a minus 2b. I know those are constant terms because they don't have any x's in them, so they're constant terms. All right. Now we've got to simplify, we've got to figure out this system of equations. Once we figure out this system of equations, we find the values of a and b, and then we can plug them back into our original partial fraction decomposition. I'm going to do something clever like, let's subtract this second equation. I'm going to say minus this entire equation from the first equation. We'll get negative 2 minus 10 is negative 12. A minus a will give me 0 a's, and b minus negative 2b will be 3b. So I end up with b equals 4. And I can use this b equals 4, plug it back into any one of those two equations to find the value of a. Let's see, 2 times 4, oh sorry, negative 4. I was going to say, I'm losing my mind there. B equals negative 4. B is negative 4, throwing it back in here and solving for a. Let's say we plug in negative 4. We have negative 2 equals a minus 4, and we get a equals 2. So now that I have the values of a and b, a is 2 and b is negative 4, I can plug them into this partial fraction decomposition, or can I also do it right here? We now have, don't forget the 1, he's still around, plus 2 over x minus 2, because I now know the value of a is 2, and I have minus 4 over x plus 1. Now it's time to integrate. I'm going to do the integration up here on the next line. When I integrate 1, I get x. Integral of 2 over x minus 2 is 2 ln of absolute value of x minus 2. And I have minus 4 ln of absolute value of x plus 1. Don't forget, and I don't think I put the bounds up here when I first wrote this, the bounds are on this guy from 0 to 1. So we're going to be evaluating this guy from 0 to 1. I'm going to plug in 1, plug in 0, and find the difference. When I plug in 1, I get 1 plus 2 ln of 1 minus 2 is negative 1, and you're not allowed to plug a negative 1 into an ln, but that's what the absolute value bars are for, so we'll say this. Minus 4 ln of 0 plus 1 is, 1 plus 1 is 2. Good job, me. Now, that's what I get when I plug in 1, minus what I get when I plug in 0. When I plug in 0, I have 0 plus 2 ln of negative 2, minus 4 ln of 1. Let's go ahead and just get this right out of the way. We know that ln of 1 is 0, so that's gone. And absolute value of negative 1, that's positive 1, so that's also gone. So what am I left with? I'm left with a 1. And I have a minus 4 ln of 2. And careful, don't say plus 2 ln of 2, but this minus 4 ln of 2 minus 2 ln of 2 there. So we end up with 1 minus a total of 6 ln of 2. And this is our final answer. And that is a partial fraction decomposition problem. Notice that, to recap, we need to do long division first. That kicks off this problem, and then we follow the usual steps of getting a common denominator, solving the system of equations, and then integrating and evaluating where our bounds.